All right, so for study guide 2-1, the chemistry portion, we already talked about synthesis and decomp on the last video. So this video, I'm going to talk about single displacement and double displacement. So let's look at single displacement and see what this means. And this can also be called single replacement. Both completely acceptable, just depends on who you're talking to, what book you look at, where you read it. I mean, they're both interchangeable. Just it's basically personal preference of the chemistry teacher or the professor that you would hear one over the other. So single displacement indicates that one thing is being displaced or replaced. So we could have A plus BC yields AC plus B. So what that means, A was by himself, B and C were together in a compound or a molecule. A displaced or replaced B and winds up with AC in its own little compound, and B is now left alone. One item was kicked out. The other way we could write this is AB plus C yields AC plus B. Now I know you're looking at the products and going, well, they're the same. For this, they are. When we actually start writing these, you'll notice that they're not. Okay, so what I mean by that is we have AB plus C. So notice this time it's the back half of the compound or the anion that is getting replaced or displaced. So C is kicking out, B coming together as AC plus B. So let's put this into actual chemistry use now. So let's take magnesium and we're going to combine that with aluminum chloride. Now, as I say aluminum chloride, you would look at charges. Aluminum is a 3 positive, chlorine's a -1, which is AlCl3. I cannot stress the importance enough that you have to look up the charges before you write out chemical formulas. That is the #1 thing that will cause you to get all these equations wrong. So if I say aluminum chloride, you can't just go AlCl. That is not how they're going to combine. You must always look up the charges, write out the correct formula before you do the rest of the equation. All right, so we're going to look at this and go, okay, magnesium, he's typically a 2 positive, and I'm just getting that from my periodic table. So if you don't believe me, here you go. Magnesium's a 2 positive, aluminum was a 3 positive, and chlorine was a -1. Okay, so that's where I got those numbers. So notice you have 2 cations and 1 anion. This is going to be called a cationic single displacement or replacement because there's 2 of them, so 1 cation can replace the other. Now, for this year, for advanced cyanide, it's always going to work out. I'm always going to give you an equation and you're just going to assume that they're going to replace each other. When you take chemistry, you find out that not everything always kicks the other one out. Not a concern for advanced cyanide, will be when you take chem. Okay, so just know that. It doesn't always work this way, but for your knowledge this year it will. So if magnesium's a 2 positive and chlorine's a -1, on the other side we will have MgCl2. Okay, so let's point that out again. I had a cation, an anion. So this cation is going to replace or displace, kick out the aluminum, and combine with the chlorine. So a 2 positive and a 1 negative is MgCl2. This leaves aluminum left over by himself. So a cationic single displacement. So let's check charges here. We have 1 magnesium, 1 magnesium, 1 aluminum, 1 aluminum, 3 chlorine and 2 chlorine. Closest way to get these 2 together is 6. Means I'm going to put a 3 here, a 2 here. That gets me to 6 chlorine, 6 chlorine, 3 Mgs. So I put a 3 here, 2 Als, 2 Als. This is your balanced chemical equation for a cationic single displacement. So remember, cations, the positive, so remember how to remember that. Calcium is a positive ion. So if you look at the word, calcium's a positive ion, cation. That tells you that the positive is that. And I'll go back and show you where I got that. Calcium is a positive, happens to be a +2 ion. So the word itself says calcium is a positive ion. Okay, let's look then at something that is anionic single displacement or replacement. Okay, so anionic single is going to be when we have 2 negatives. So let's go, let's see, magnesium fluoride, so MgF2, Okay, this is a reaction that typically would not work at all in real chemistry world, so don't hold it against me, but I promise this doesn't work. Okay, and then we're going to make this bromide, okay? And bromine is a diatom, so he's going to be a 2. This is bothering me that I gave you one that doesn't work, but it's okay. You'll see what I mean. So magnesium's a 2 positive, fluorine's a negative 1. That's why we got MgF2. Bromine is a negative 1. Yes, he's a diatom, but he's typically a negative 1. So we have 2 negatives, 2 anions, so they're going to switch places. Now, real chemistry world, nothing boots out fluorine. He's the most reactive non-metal on the table. And we're doing just practice problems, okay? So we're not going to worry about that. That's a chemistry skill. We're just worried about how these two would flip. So magnesium's going to hook up with bromine. So you're going to get Mg, and if he's a 2 and bromine's a negative 1, Mg, Br2. That means fluorine was kicked out and left alone. Fluorine is a diatom, so he's a 2. 1 Mg, 1 Mg, 2 Fs, 2 Fs, 2 Brs, 2 Brs, balanced as we wrote it out. Typically it doesn't work out that way, but it was balanced. That's an anionic single displacement, okay? So cationic single displacement, you're going to have one substance by itself and then a compound or a molecule. And same thing on the anionic. It's just if I have 2 anions, the anions are switching. If I have 2 cations, then the cations are switching. Okay, last 2 things we're going to talk about here is double displacement and hydrocarbon combustion. So double displacement or double replacement means that 2 things are switching places. So we have AB plus CD, and A is going to go with D, and C is going to go with B. And there is a very specific reason that I wrote it this way and not BC. So let's look at magnesium nitrate. Magnesium is a 2 positive. Nitrate is a polyatomic ion at negative 1. So that is MgNO3 2. Okay? Plus, let's combine that with aluminum. Let's see, hydroxide. Hydroxide is OH, negative 1. So that is Al, OH in parentheses, 3. Okay. We can tell from this that it's going to be a double displacement reaction because you've got positive, negative, positive, negative. So 2 things are able to switch places. So magnesium is going to end up with hydroxide. So Mg, OH in parentheses, 2. Because if he's giving 2 and he's taking 1, it needs 2 hydroxides to match up. Plus, now, the cation always goes first, so aluminum has to go first. Aluminum's a 3 positive, nitrate's a negative 1, so AlNO3 in parentheses, 3. There's my equation. So up here, why did I write C first? Because this would have been a cat, this would have been an anion, cation, anion. The cats always go first. That's why it's A, D, C, B. Okay, so here's your double displacement reaction. Let's go ahead and check and see if it's balanced. We have 1 Mg, 1 Mg, 2 nitrates, and 3 nitrates. So that's going to end up being a 6 is the closest number in common. Now that fixed the nitrates, but we broke the magnesium. So there's 3 of them. I'm going to come over here and put a 3 magnesium. That gives me 3 times 2 is 6 hydroxides. There's 3 over here. That's going to be a 2. 2Al, 2Al. Okay. The only other thing on double displacement reactions that I had taught you earlier this year was remember that nitrates are always aqueous or always in solution. And so this is a bad example because this guy would have already been a solid. But typically you can look at the products and go, hey, whoever's in nitrate solution is going to be aqueous. And then the one that's not usually is going to form a precipitate or solid. Not highly important yet in your life, but if you can remember that nitrates are always in solution or they're always aqueous, that could help you out if I asked what substance made a solid or whatever, okay? All right, and then the last thing I want to talk about is a hydrocarbon combustion really quickly. So hydrocarbon combustions are combustions, which means you're reacting with oxygen, but it's starting with a hydrocarbon. So methane is a hydrocarbon because it's hydrogen and carbon. It's going to go through combustion or it burns. If we say something burns in air, what it's burning in is oxygen. Air is a mixture of a whole bunch of gases, but what allows something to burn is oxygen, okay? So what happens in a hydrocarbon combustion is the carbon is going to end up with the oxygen, and so is the hydrogen. So we get carbon dioxide and water every time you have a hydrocarbon combustion reaction. I could take C6H12O6, run it through combustion, this is otherwise known as glucose, and you still get CO2 plus H2O. This will be something that's important next year when you guys learn photosynthesis and respiration and those kind of things. You'll see this equation again. All right, so let's look at methane and see if we can balance it. We had one carbon, 4 hydrogen, 2, so I'm going to put a 2 here. 2 oxygen plus 2 is 4. This needs to be a 2. So this is a hydrocarbon combustion balanced. All right, down here I have 6 carbon, 1 carbon, put in a 6. 12 or hydrogen, 2, there's a 6. This side I have 6 times 2 is 12, plus 6 is 18 oxygen. On this side I have 8. Here's what you want to do. You want to take these 6 off of that 18 total, because you don't want to change anything about the C6H12O6. You don't want to put a coefficient in here and change everything that you just fixed. So we had 18 of them. So 18 minus 6 is 12. How do I get to 12 here? I put a 6. And those are your coefficients. All right, so remember, for your chemical reactions, you have synthesis, decomp, single, double. Single comes down to cation, and you have combustion, which is reacting with oxygen, and a hydrocarbon combustion is hydrogen and carbon reacting with oxygen to always produce carbon dioxide and water. Work through study guide 2-1. The toughest thing is predicting the products. Look at what kind of reaction it is, and then see how is the substance going to come together? How's it going to break apart? How's it going to flip? Work through the questions, any of them that you have that you don't understand. Take notes on them or screenshot them and send them to me, and then I can send you an audio message back or a quick video back, or I can just send you an explanation back, whatever you need. All right? Let me know if there's anything you guys need.